This tutorial discusses how to import a DXF file into TRISCO. You can download the corresponding files from the link mentioned at the description of the video. In this example, we choose AutoCAD to generate the drawing. Each of the closed polyline must be loaded into a different layer name with its material property. It's important for the polyline to be closed in order to rasterize the bitmap in TRISCO. You can convert the line segment drawing into closed polyline by choosing boundary command in AutoCAD, which would automatically generate polyline in the closed boundary. Now, start the TRISCO application. In File menu, open TRISCO DXF and select the file which we wish to import. A dialog box opens allowing to select layers which should not be recognized. If you wish not to import some specific layer, you can select that. In our case, we would like to import all layers. Upon clicking OK, all the layers are recognized in DXF. The DXF drawing window displays the corresponding lines in gray, all layers except the current layer, and black, for lines of the current layer. In the Layers dialog box, you can notice layer name, fill mode, and color. Color here is linked to TRISCO color database, which represents material property or boundary conditions as per EN ISO standards. As we click on each layer, the corresponding polyline in DXF viewport gets highlighted. Now we shall assign each of the layer with its corresponding color in our example. You can let the fill mode be as contour for now and then click Calculate Bitmap at top toolbar, which is represented with magic wand. Now you see the input colors reflected at the bitmap. Alternatively, it is also possible to add the fill mode and color info to the DXF layer names, and TRISCO would automatically recognize this. The first prefix in the layer name corresponds to the color number, and the second prefix corresponds to fill mode, with 1 for fill contour and 2 for flood fill. Now you can see that the information is automatically processed by TRISCO in the Layers toolbar. If we calculate bitmap, you can now see the rasterized image again. Every time you make some change or click at Layers tab, you would need to calculate again. We shall be exploring few more tools in TRISCO DXF window before we save the file. But once you save the bitmap file, which in .bmp format, together with we also get a .lay file which contains layer definitions. When any other DXF file in future must be converted to bitmap. The same layer definitions can be reloaded from Layers tab and load layer definitions, or can be installed as default layer definitions, which copies into TRISCO DXF.lay in AppData. We shall now explore various settings at fill mode. We shall choose indoor horizontal layer, and as you have seen previously, fill continuous will rasterize the polyline by filling color inside the shape. Now we double-click to change it into different modes. Flood fill would fill the color inside the shape and also its surroundings till adjacent boundary curve. Skip would ignore the layer when rasterized into bitmap. Line would just fill the color for the outline of the shape. Hence, for boundary conditions we choose flood fill and then calculate the bitmap. The blue boundary represents the bitmap outline. This can be modified from bitmap window or bitmap icon. Draw bitmap allows you to draw a free rectangle with diagonal points. Using set bitmap size and resolution, you can give the coordinates of all 4 vertices of boundary, and the pixel resolution here represents units. We made our drawing in centimeter, so resolution will be 0.1 as we need grid unit in millimeter. The order of layer represents its priority, with higher priority towards bottom. You can change the priority using the arrow symbols on the toolbar, either by moving the layer on top or bottom. Once everything is ready, we can calculate the bitmap and save it by clicking on Save icon or at Calculate window. Now you can close your TRISCO DXF window, and TRISCO would automatically detect the bitmap and asks permission to convert bitmap into blocks using superposition. Superposition will overlay the box which is set on higher priority over the layer which have lower priority. By clicking Yes, you can now choose projection plane of your DXF drawing. We choose XZ plane, and object depth here represents extrusion perpendicular to the plane. Set the grid unit to 0.001 m, as the pixel size of the imported bitmap was 1 mm. You have now imported the bitmap which converted into blocks at TRISCO. You can orbit your window and check the imported object. Now you can see the list blocks imported and corresponding minimum grid required for generating of blocks. This grid is not sufficient for analysis, as this is only to generate geometry. Hence we further refine by choosing Auto Split at Grid window. Auto Split will automatically subdivide grid, and we choose X and Z as we projected our bitmap at XZ plane. For smaller meshes up to 5 mm, the grid would split into equal segments of 1 mm each. Meshes larger than 5 mm would split, increasing its distance with ratio of 1.5 as it goes away from the boundary conditions. We click OK and see that our grid has increased and is more refined for analysis. You can select the grid and the selection would get highlighted on your viewport. Now, at Edit menu, select Derived Thermal Properties. Select the parameters you wish to analyze from the list available. For this example we choose temperature factor and linear thermal transmittance. Then click on Calculate Bitmap to run analysis. Our analysis is now ready. Click on the text output to check the values of derived parameters and other properties used during analysis. See you at next video.